Okay, let us now look at question 2. Okay, it's another DC circuit question. It says that, okay, once you see some information here, which is ammeter is 2 ampere, ammeter is actually measuring the amount of current that flows in the circuit. So in this case, let us examine the circuit. There's actually a line joining here. So if we see 2 ampere current here, we should try to indicate onto the diagram itself. Okay, so in this case, 9V is actually my EMF due to this battery source, and the current will flow from the positive, which is the longer line, through the circuit and come back to this negative terminal. So this is how the current will flow, and this is actually known as a series circuit. Okay, so what do we know about a series circuit? In the series circuit, the current that flows through at this end will be equal to the amount of current that flows through X, and also will be the same amount of current that flows through the 3 ohm resistor. So this is a very important concept. The current is the same at any point along the circuit. So let's look at the question now. What is the value of the potential difference across resistors X? Potential difference in this case is actually looking for this thing called voltage V. So how do we find V? Okay, as you can see, the entire circuit has a EMF, or even we can call it as a voltage. So the total voltage of this entire circuit is actually 9V. If we can recall, there's a relationship which is the E in a circuit is actually equal to the sum of the individual potential difference across each component. So in this case, if I say across here has a voltage of V1 and across here is a potential difference of V2, I can actually form an equation known as E is equal to V1 plus V2. So this is a very important concept to solve this question, because actually I'm looking for V. In this case, it's actually V2. So how can I find V2? This is EMF is given as 9. Is there a way to find V1? As you can recall, there's a triangle relationship, which is V, I, R. So in this case, V1 is actually, I can cover my V, and so my V is actually equal to I times R. So in this case, my I times R is actually my current, which is 2, my current I, which is 2. So in this case, my V1 is actually equal to 2 times my R. So my R here is actually 3. So it's actually 6V. So I transform my answer here is 2 times 3 plus V2, which is what I'm trying to look out for, which is the potential difference across X. So in this case, I do my maths. 9 is equal to 6 plus V2. So V2 will be equal to 9 minus 6. So the answer in this case is 3V, which is C. Okay, that's all about this question.